Another episode of the Unitartutech podcast is coming your way, which is the podcast for the University of Tartu
Institute of Technology.
Kristjan, let's start with your academic studies.
My bachelor's degree actually I didn't do in Tartu University, but I went to then Clevon Academy, which is now Clevon Academy, and I got robotics software development bachelor's degree from there. Master's degree I started last year's autumn in Tartu University. The program is called Robotics and Computer Engineering, and it's in English. Doing my bachelor's thesis, I discovered that doing it in Estonian is quite difficult because of the terminology and whatever. So writing it, to me personally, it's more easy to write in English. I mean, I have a lot of experience in English. I've lived abroad, so it doesn't really make that big of a difference for me. But I guess for people who have never left Estonia and have always studied in Estonian, it's probably a good leg up because in tech companies, a lot of the time, the working language is English. So it's good to get some practice in.
When you first joined Clevon, what was the driving force behind that?
I was currently working as a kind of CAD person for a metal company, and I'd risen in the ranks to this, not glass ceiling, but I guess just there wasn't anything more for me with my, at the time, education. But the academy gave me an opportunity to leave work and take up studies. I mean, I'm not the 20-year-old, so I have expenditures in life. I have a house I need to pay a loan on. But joining the academy, they had a scholarship program as well. So that gave me the chance to actually do it.
Did it prepare you well for the master's?
Yeah, I'd say definitely, because I mean, at the time we were the first year, so a lot of what we studied, we had a say in as well. It was quite fluid, the lectures that were chosen for each semester. We had one semester, then we had to give feedback on how it went, how well we thought it prepares us for the actual work. For example, machine learning, for example. I did that actually already in bachelor's, but Dimas' lecture was definitely very nice.
Oh, okay, awesome. So it has interdisciplinary elements.
Yeah, definitely. Actually, for the first semester, the way I picked my courses was I looked up where they were held, so I picked everything in Delta because it's quite close by, so it's easier for me to go from work to Delta and then back, and because going to Nooruse is bus ride instead of walking 5 minutes.
How would you describe how the master's program at the Institute of Technology is beneficial for you here at Clevon?
In Clevon, I have kind of specialized in a certain area of what I do day to day. But for the master's program also, it's more varied. I get to practice other things as well. So I'm dealing with perception and simulation at my day-to-day work, but I can also do planning and control stuff at the lectures. Simulation is just me integrating our existing software with the simulation so we can test out things not in the real world, but simulate them.
How much of a team effort does it take?
Since I'm the only one working at the moment on that, I don't really have a team. But altogether, the whole of the software side, it's definitely a big team effort because the software I'm integrating with the simulator, it's all written by tens of different people. So of course I have to interact with them, and for some things I don't know how they work, so then I'll just go and talk to the people who made them. And then it's a lot faster than just trying to figure it out by myself.
We all know that you also participated for a long time at the Solaride, so you guys were in Australia, you were really successful.
I guess if I would have continued with Solaride, I would have probably not taken the master's because of just the workload. But in that sense that finishing the season, now I have time to actually study more. So in that sense it did. But yeah.
So it was a student project that was really time consuming.
In Solaride, all of the work we did was basically from the spare time, but for work you have allocated 8 hours every day, so it's you have so much more time. It's not compressed into one single weekend or something like that. My work here at Clevon probably influenced my work in Solaride more because of the experience of working in a team, how software management is done and stuff like that. It carries on. Well, I tried to at least carry it on to the Solaride project as well too.
Your course mates, are they cool guys to study and deliver school projects with?
Definitely. I mean, I'm studying in English, obviously, so we have quite a few Erasmus exchange students, but also people who have actually traveled to Estonia to take the program here. For example, one guy from Ghana, Africa, he's really cool, and he's been to MIT as well. So we did a project with him together, and he's really motivated. But yeah, since I'm also working, I don't have that much free time to go and do extracurricular activities with the other students. So yeah, they seem nice, but I don't really know them that well yet. I mean, still 1.5 years to go, so probably will get to know them.
How do you sense yourself making a difference in the world, being an engineer?
Well, we here at Clevon are creating the future, so without engineering, there's no way to progress in that kind of sense. Also, yeah, going to events like Startup Day or the Delta Career Day, for example, I think we inspire a lot of young people to get into engineering because when they see some cool stuff like robots driving around, it's an eye-opener.
Were they interested at Startup Day?
Yeah, definitely. And it's like one of the themes is whenever we do our presentation with the control station and there's a vehicle driving in the test site in Viljandi, a lot of the people always come and say like, oh, it's not a simulation, it's actually a real car. And in my mind, it's like, okay, it's like to have a simulation that good, I'd be really proud, you know. Yeah, it really amazes people, and it's good to see, and I think it probably will influence their choices for education as well.
And how will it influence everyday people's lives? We will have more comforts, more...
More comforts is one thing, but it's also good for the environment because instead of carrying a pizza with a diesel van, you get a small electric vehicle that doesn't burn fossil fuels as much, and it's more efficient in every sense.
When I hear electric vehicle, I think about batteries, and then I think about the second law of...
Second law of thermodynamics.
Exactly. So how far are we with batteries that don't give out energy due to thermal
losses? Well, you can never get to 100% efficiency. When we were at the Solar Challenge, a lot of the teams, well, not a lot, but some of the teams were using the silicon-based batteries already, which is basically another step up, moving away from lithium eventually to get more and more efficient.
I think with lithium there's also this concern that it's not really good for the environment.
Well, lithium itself is okay, it's just the way that it's extracted from the soil.
So with silicone it's another ball game.
Yeah, I mean silicon is basically sand.
So it's innovation in a sense. And
definitely.
You guys didn't apply this one.
I'm not so sure about what they will decide for this season, but I know that they're aware of this, and I'm not sure if they've been talking with the company that is pretty much the only company that produces these batteries right now.
But what are the most interesting fields where innovation is happening right now? I know, okay, batteries, one thing, supercapacitors, right?
Yeah, like skeleton technologies. Yeah, supercapacitors are more useful if you want to deliver a lot of power at once for fusion reactors or something. But for batteries are still the ones for EVs right now.
But how far are we from a future where fusion happens in Clevon autonomous vehicles?
Fusion in an actual vehicle, that's probably science fiction more like. Right now, the ones they're test facilities they're building, they're huge, and so yeah.
Like the Hadron Collider
Not
stuff?
Not that big, but yeah.
Okay, cool. But what's the main thing holding this fusion reactor on a small vehicle stuff behind?
Well, I mean, room temperature superconductors would probably be a good thing because you need huge magnetic fields to confine the plasma that's fused, or maybe just a completely new approach. If you see a lightning, that's plasma as well. It's like the ionized gases, basically. But yeah, the temperatures that they use in fusion reactors, it's hotter than the surface of the sun, so you can't really use conventional materials to contain that.
This is the 4th Unitartutech podcast of the University of Tartu
Institute of Technology.